Hello everybody, this is Daniel Rodriguez. I'm a professor of public health, an associate professor of public health at LaSalle University, and this is an introductory set of videos to help you get through your statistics course. And I know statistics is very hard for individuals, so I'm going to provide these videos that you can use and you can watch them over and over again. Hopefully it'll be of some help. I'm also using I finally got my Wacom tablet, bamboo tablet back, so I was excited. It wasn't working for a while. I got it to work again, so let us go. So here we have some data here, okay? And these data are going to be used to help us calculate a variance. So first we'll start with the mean and then the variance. The mean is just the average of a set of values. In this case we have 15 different values. These are giant slalom runs for those of you who like skiing, and you have the age of the individuals who are running the giant slalom course, and then their time in seconds. Of course we have their ID. The only thing we're interested in this case is getting the variance of the giant slalom run. So time on the run. But we need a couple of pieces of information there. First we need to summate all of these values. Summing is, and I'm going to just show you a couple of symbols here to make sure that you understand everything. So let me go to this tablet here. This is a drawing tablet. It's not necessarily a mathematics tablet, but you know, I'm using this as a way to start. Let me just locate my pad here. I don't need that. So here's my. There you are. I think here it is. Here's my pen. So I don't want this thing. So let's get rid of that. All right. So the sum symbol, you'll see it looks like a sigma, right? And so let's actually use a ballpoint pen. So it's a sigma. Sigma means a sum. So when you have a sigma, say we'll start with I equals 1 to say n, right? It means we're going to summate over a set of values, right? In this case, let's say we're going to summate the different race GS times. So we'll say let x equal GS time, right? GS time. So x equals GS time. I is the individual, so I have a certain number of individuals. So if we go back to this prior sheet here, we have 15 individuals. So with there being 15 individuals, so we'll have n is equal to 15, right? So when I draw this symbol here, the sigma is actually I equals 1 to 15, right? And each person will have a score on the giant slalom. So it'll vary by individual, so that's why we have the individual here. So what this sigma means is then we're adding, say we're going to add up x sub 1 plus x sub 2 plus x sub 3, let's put a plus sign here, to x sub 15. It'll give us the sum of those 15 values. So that's what that means. Now for the mean here, so the mean is represented from a sample mean, and this is part of inferential statistics. We're trying to make an inference about the population mean. Mean is a sampled mean. It's a really nice estimator of the population mean. Population mean will use Greek letters. Like in this case, we use the Greek letter mu to mean the population mean. Okay, but we don't know the population mean, so we use samples to estimate the population mean. And we can talk about that some other time, how that all works out. But we need to calculate the sample mean, and we'll use the sample mean as an estimate of the population mean. If we were to gather the mean of every single sample of a specific size, say size 15 from the population, and we took the mean of all of those samples, and we were to make a distribution of all those means, the mean of all of those means would be the population mean, right? And then we'll talk later about what the standard error is. The standard error would be the standard deviation of those population means. So it'll be the standard error of the mean, but we don't have that yet, so we're just going to summate all the different values, right, like we did. I'm going to avoid writing this stuff down here because it's cumbersome. So summate all the x sub i's, right, and we're going to divide that by the sample size. And that's your standard definition of the average, right? So we need to get that Now, as you can see, go backwards to that table that we had here. We're going to use this table, and I don't want to do all this work by hand, to be honest. So instead, I'll plug my Excel spreadsheet, and I'll copy and paste all this material in here. Right? As you can see, I already have the standard deviation there, but we'll talk about that in a minute. I'm going to copy this, and I'll go ahead and paste that into the spreadsheet. Paste that in the spreadsheet. Of course, it can be pasted. I'll delete that value. We don't need that right now. And I need the sum of these values here. Okay, so let's sum them up. You have this function in Excel. See, there's a sigma right there, right? You click the sigma, and it'll tell me that it'll show me what I'll be summing. We'll be summing the values above them, and I'll be putting it in this cell here, right? Starting from C sub 5 to C sub 19. I just hit enter, and it'll give me that sum. So I need that sum, 628.42, 628.42. So let's go back to our tablet. So what did I say? 628.42. So if we sum this up, right? If we sum this up, we get 628.42, right? 628.42. Very nice. Okay, so we have that. Now, so we keep that value in mind, right? We'll keep that value in mind, and we're going to use that to calculate the variance. Okay, so let's just clear this up. We don't need this anymore. Edit, clear. Now we want to go ahead and calculate the variance. So the variance, for the sample variance, we use S squared. That's our sample variance. This is an estimate of the population variance, right? This sigma squared. I know we were dealing with the sigma already using it, but this is also a sigma squared here. Okay, this is a sigma squared. This is the sign of the population variance. Okay, variance represents the variability of some value around the mean, and this is clearly seen from the formula, right? So let's go with the sample variance and the formula here. We'll see is that we're going to have to summate. We're going to have to summate the difference between each value and the mean. And look at this. This is interesting. So we have the x sub I, right? That's each individual value. And we're going to subtract the sample mean from it. You'll notice that first thing we'll notice is that the sample mean does not have a sub I. The reason for that is that the mean is the mean, and it doesn't vary from individual to individual. Of course, the other values do. If we were to just subtract the mean from each value, some of the values will be above the mean, and some of the values will be below the mean. When we sum them up, we'd come up with a value of 0, and of course 0 does not represent a measure of the variability, so instead of just summing them straight like that, we actually square this difference. So this is called a sum of square difference, or a sum of squares difference. And then we divide this, we take the average sum of squares difference, and we divide it by n minus 1. We lose a degree of freedom because we're making an estimate of the population mean from the sample here, right? So we lose 1 degree of freedom. Now, we can talk later about degrees of freedom. That's a whole different topic. Because you notice that when we're using the population values, right? When we're using the population values, we wouldn't be subtracting that n minus 1, right? Take each individual value, each individual x sub I, right? We subtract from it the population mean, square it, and divide by n, right? Okay, so here's our variability. Okay, so now, but that's not really essential for us here. I'm just interested in showing you how to calculate the variance. Erase all this stuff right here. Okay, so, well, that means we need to do several things. We need to calculate these different scores, right? We need, and there's actually another video where I show you a shortcut formula for this. But let's not worry about that now. Let's work with what we have here. So we're going to go into And back to our data, and we need the difference between each value and the mean, so let's go ahead and do this. Let's call this a difference square. We'll put the mean here, right? The mean in each circumstance. And we're going to do this calculation. The mean, as we had it already, 628.42, right? So we're going to have to subtract. Oh, I'm sorry. That's the sum, right? That's the sum. Did I say that was the mean? That's the sum, right? I don't know if I ever finished calculating the mean. Well, if I didn't do that, then you can get me for that. So we had to divide 628 by 15. I think I forgot that. Oh, what the heck, right? What the heck is he doing? So let's go back here for a second. So let's go back to this, and here we have the mean, right? Is equal to 628.42. 628.42, right? 0.42, and we divided that by 15, right? So I don't know what I was thinking there. Okay, so go ahead and do that. 628.42 divided by 15, and it'll give us 41.89. Let's go 41.89. Here's 41.89. 41.89. So let's go back to that spreadsheet, 41.89 here. So I have the sum, so the mean, then it would be, and you can also see how I'm doing this in Excel, because you can do these functions in Excel. I'll take this value and divide it by 15, right? And you can see that you can work everything in this little window up here, right? We enter, and we get the same value here, okay? That's our mean value. All right, so now we need, actually we're going to calculate the difference here. Difference. Let's spread that out a little bit. Hey, come on. There you go. Difference. All right, so difference is going to be equal to, and you'll notice how I use Excel to do a lot of these calculations. I need the difference between each value, so it'll give me the cell value when I highlight it. You start everything by using the equal sign. When you enter equal, it'll tell you that an equation is coming, or some kind of function is coming. So I subtract from that the mean value. I'm not going to highlight this mean, because if I did that, the formula would be altered every single time I do it. I'm just going to write in the mean value as 41.89. 41.89. Okay. So in this case, you'll see the value is lower than the mean. Go all the way down here, we'll get all the differences. Actually, let's do something for fun, and let's just sum this here and see what happens. I said it's supposed to equal 0, right? Wait. Oops, did not come up here. Let's try this. There you go. It's basically 0, right? So, if I were to sum up, notice how I drag this, by the way, I drag this box because this one contained formula for, oh, actually it's the mean, I'm sorry. This one contained the formula for the sum, right? So I'm going to sum these different scores, and when I pull this over, it'll give me 0.07. So it's essentially 0, showing me that there's no variability, right? That's not the case here, right? So there is variability. So by squaring the difference, so S diff, we'll get the numerator for our equation, because the numerator is the difference. So far what we've done is the difference between each value and its mean, right? So x of I minus the mean, and we get essentially 0 there. So let's go ahead and now square it. So I'll go back into my book of tricks here. In this case, I'm going to hit the function key, and I'm going to look for the function. So if I go under math and trig, I could find the power function, right? That's what we're doing. Here it is, power. So here we have the power of a certain number. So let's click that. The number we want power of is this one. It's located in cell D5, right? And the power we want is 2, so we're going to be squaring it, right? See, is the exponent to which the base number is raised. So we hit OK. We get that, right? If we drag this down here, we'll get the square of this value, and so on, and so on, and so on. So now we have a bunch of positive values, right? Perfect. Now we want that numerator is going to be what? The sum of the differences squared, right? Well, here's the sum, the difference. Oh, excuse me. We did it once, but we want the sum of the difference square. So we're going to take each of these differences, right? We squared them. This is what this formula is saying. It says take the difference between the value and the mean, square it, and then add it to the next one and to the next one, going from I equals 1 to n, right? So we're going to do that from I equals 1, 2, 3, 4, all the way to 15. So here we did a sum, right? So let's go ahead and drag this over so it'll do a sum for the other values in this. In column E, and it did that, and we get 25.8287. Alright, so we can put that in there, 25.8287. So equals, so 25.8287, so 25.83, and divided by 15 minus 1, n is 15, 1 is 14, and minus 1 is 14, so it's divided by 14, right? Finally, we can now do this division here, and we really don't need Excel for that, right? It's 25.83 divided by 14, and we get 1.845. 1.845. We get 1.845. Oops, sorry, 1.845. There you go. Let me erase that little thingy. Make sure you don't get confused with my eraser. There you go. I like this little thingy. There you go. Alrighty, so here we go. Got 1.845. Let's go back to Excel and see if we can match that to get our variance. So here's our mean. Here's our sum of squares, and if we divide it by, well, we're not going to do the mean here. Instead, what I'm going to do is I'm just going to do the variance. And here we're going to let Excel do it, so we can see if we did a good job with our calculation. So I go under Excel. Variance would be found under Statistics. Statistical. And so we'll go to the variance. Let's see, where are we? Standard deviation. Variance. What's the difference? Oh, variance of sample. Let's move on. Okay, right. Hit OK. And it'll do it for the values E5 to E21. Well, that's not what we want, actually. We want it for the original values here. Starting here, right? To here. So I could just drag and carry the cursor over all the values I'm going to use. Let's see, change that to C5 to C15, C5 to C19, and hit OK. What do I get? I get 1.84484. Let's see what I got here. 1.845. Same thing, right? There we go. So that verifies our calculation. Now, last thing we need, though, we don't like using the variance, right? Instead, we use the standard deviation. Okay, so we calculate, if we use the standard deviation instead of the variance. We know a lot about the standard deviation when there's a normal distribution. A normal distribution looks like something like this. It's an inverted U, or you can say, that's not the best drawer. It's like a bell-shaped curve, right? Here's the mean right down the middle, and then we'll have, standard deviations going around the mean. If in a normal distribution, right, in a standard normal distribution, we have 68% of the sample lying between plus or minus 1 standard deviation. 95%, I wish I could draw better, but 95% of the sample between plus or minus 2 standard deviations. And then if we drag this out a little more to plus or minus 3 standard deviation, we have 99.7% of the population. So we have, that's called our 68, 95, 99.7 rule. So we know a lot when we deal with standard deviations. Plus, the standard deviation is not so subject to the influence of additional values, right? As the variance is. Okay, so the variance will keep on increasing the more values we add in there, right? So what we're going to do now is we're going to take the square root of this variance. So the square root of the variance is right here. That'll equal the square root of the variance, and that's called our standard deviation. And our standard deviation is 1.845. It's 1.845, and we take its square root, we get 1.34. So our standard deviation is 1.34. Okay. So what does this tell us? Well, okay, we have a mean. A mean is equal to 41.89 with a standard deviation equal to 1.34. So we know that our average race time was 41.89 seconds, and that 68% of the racers were between plus or minus 1.34 seconds from that mean. Okay? So let's see if we can just go back to Excel and just finish this up here. We need our standard deviation. Standard deviation. Just take the square root of this value here, or we can just go back to Excel and let it calculate. Let's go ahead and do that. So let's find the standard deviation. Standard deviation. There we go. For the sample. And we'll take the standard deviation for that same sample. Again, we're going to highlight these values here. So we go C5 to C19, and it equals 1.358. Is what I got? 1.358. That's pretty close. I'm a little bit off here, but you know that's okay. Just a little bit off from that, and that's it. That's it. Okay. So that's how you calculate the mean, variance, and standard deviation. All right. Thank you very much. Bye.